Hello everyone. In this series of learning data structures, today we are going to see few sample programs on dynamic memory allocation. So let's start with program. So here is one sample program. So I am creating a file with name sample.c. And what this program will do, we will write a program to store marks of n students, and then we will calculate the average using dynamic memory allocation concepts. Okay, so what we can do, let us suppose I have n number of students. Let us suppose n value is 4. So 4 students, I have to ask user to enter marks. Now to entering marks for if I'm talking or if I'm assuming marks are in float or data type, then I need that much space for 4 bytes, because float take again 4 bytes. So 4 bytes for each student's marks. So here I have to dynamically allocate those 4 bytes for 4 students. So this we will see here. Let me include header file. Hash include std io.h standard input, and another I have hash include std lib.h, which is standard library file. Now here is my main function. So void main. We can dynamically allocate the memory using Malloc function also, Calloc also. So one by one we will see using both. So float. Now I need a pointer variable because we have already studied the concept of dynamically memory allocation, and we know we need a pointer variable to point to the base address after memory allocation. Now after computing students, after asking user to enter students marks, I have to find out the average. Then so for finding out average, let me take a variable with name average, or first I have to do sum and then I will calculate average. So here I'm taking one variable as sum and I'm initializing it to 0, so it will not have any garbage value. I'm asking user to insert number of students. For that I need one variable that can hold how many students I have for that n, and because more than one student I will be needing a loop, so for that I'm initializing one variable as I. So let's start the program and ask user how many students are actually there. So printf enter the number of students. Now user will enter, so that value I'm putting in scanf. So here is scanf. So that value we are storing at variable n. Now we have to do dynamic memory allocation, and if you can see, marks will be of, I'm assuming marks will be of float type. So here I'm writing this pointer variable casting type. Here I'm writing float. So this is my casting type. Right now I'm doing dynamic allocation using Malloc. Later I will update the same program using Calloc as well. We know that Malloc takes only one argument, so n into, and here size of, now casting type is float, my pointer is float, so here it will be size of float. Right, so it will allocate the memory to these n, whatever value is there for this n. Float type of memory will be allocated to it. Now we have to check whether dynamic memory allocation is done or not. So for that, we are writing the condition if, and this pointer variable, if this ptr is pointing to null, that means dynamic memory allocation is failed, it's not done. So we will print a message if ptr is equals to null, then we have to print here message printf memory allocation failed. Like this, we will give the message. And if memory allocation is failed, we will come out from the program. Why we will execute remaining line. So to coming out for the program, we have here exit 1. What exit 1 does, it will take you out from entire program. How you can use exit 1 for using exit 1, you have to include std lib.h, which we are already using because we are using dynamic memory allocation functions such as malloc and free and all. So we can use this. Now we will see if this is not the case. If pointer is not equals to null, that means dynamic memory allocation is done. So to check that dynamic memory allocation is done, I'm applying a loop. So for I is equals to 0, how long I should go? Less than this n, because if there are 5 students, as we know, array takes from 0 to 4. So less than this n, we will run a loop. So I should be less than n, and every time I will do one increment. Here we will ask user to enter the marks. So here I am asking user printf enter marks. Now what I want, it should print me like this: enter marks of first student, enter marks of second student, like this I want. So for that I am writing enter marks for, now if you can see, when I value is 0, that means actually that is my first student. So I will write enter marks for first student, and how I will point out to that, I plus 1, because when I value is 0, I am talking about first student. When I value is 1, I am talking about second student, and I value is actually integer. So format specifier will be %d. So here enter marks for then for format specifier for integer %d student, and here I should give I plus 1. So every time it will increment by 1 and then it will print to us, right? Here I'm missing one comma. This comma should come here. Printf syntax. Now user will insert a value, so we have to read it now. So here scanf. Now what kind of value user will insert? All the blocks are of float type. That means it can accommodate float type value only. So if it can accommodate float type value only, then user has to enter a float type value. If user is not entering float type value, automatically my compiler will do typecasting. If user is entering, for example, 15, it will consider it as 15.000, right? So still for us, if somebody is entering 4.9 or 15.8, so for that, to accommodate that 0.8, what we have to do, we have to use the format specifier as %f. Now how to locate or how to point out which place this should go? Now as you can see, we have a ptr. This ptr is pointing to the first location. If you remember, let us suppose the size of this n is 4. Float take 4 byte. That means 4 into 4. 16 bytes are allocated in the memory. And this PTR is pointing to the first base address. Now PTR is a pointer variable. Pointer has the capacity. Pointer is that variable that holds the address of another variable. So this PTR is holding the address of first base block. Now what is happening? First value is coming. How to tell compiler that go and store that value? For example, some 20.2. This is the first value. How to tell my compiler now to store the value here? So PTR is pointing to this location. PTR contains address. So if I will write PTR plus I, PTR plus I means this PTR for 0, PTR for 1, PTR for 2. So I will allocate the memory addresses here. For this, your pointer concept should be clear, then all this logic will be very easily understandable. So what we have to do, using PTR as base, we will work forward. So where I should store? I should store at PTR plus 1. Sorry, I. Because I will be 0, I will be 1. Like this, I will store the value. Why I am not using ampersand here? Because already PTR contains the address. Now, a value for PTR is address of this particular block, right? So PTR plus I am using. So using this, what we will do, all the memory blocks will get the value using this. Now what we have to do, we have to now find out the sum so we can do the average, right? So here, because ultimately the aim of the program is, after allocation, store the n students marks and then calculate the average. So now again I need a loop. For that I am putting a loop, and here what I have to do, I have to find out the sum. So how to find out the sum? I will use sum is equals to sum plus, and then value pointed by this PTR0, PTR1, PTR2. So sum is equals to sum plus, and using this pointer variable, I will fetch the value from those locations. So here I will write this. This is a dereference operator. This star is a dereference operator. How it will work? Value pointed by PTR plus I. So the values which are pointed by these locations will come in front of me. For example, if I am talking about 4 students, let us suppose this location is PT. This location we will call as 0 location. This location is first, this is second, and this is third. When I value is 0, here is a pointer variable that holds the address. I'm assuming this location has the address 200. This will be 204, 4 bytes difference. This will be 208. This will be 212. This is the PTR variable. Initially, it has the base address. That means this first address. That means what? This PTR is pointing here. So when I is equals to 0, PTR is 0, PTR is 0, and because of this dereference star, how we will pronounce it? Value pointed by PTR 0. What is the value which is present at PTR 0? Let us suppose here the value is 15.2. So what will happen? If you remember in the beginning, we have initialized sum is equals to 0. So 0 plus 15.2, and that we will allocate in another variable, and that variable name is sum. So inside sum, this 15.2 will go. Next, what will happen? I value will increment. This time it will be PTR1. So instead of 200, now my PTR will point to this location. So when it will point to this location, what is the value present inside? On the basis of that, things will change. Let us suppose here 1.3 is present. So what happens? Sum plus value pointed by ptr 1. So here if you can see, the value pointed by this is how much now? 1.3. So what will happen? 15 plus 1.3. So it will be 16.5. And so on and so forth. It will go on like this. So all these concepts will be clear once your pointer concepts are clear. So for this dynamic memory allocation, in fact, for further topics of data structure, your pointer concepts should be very clear. Then only you will be able to understand. Now what I have to do, I have to compute the average. So what I should do, either you can do sum divided by average is equals to sum divided by n. You can do like this, or using printf also, inside printf also you can print. So what we can do here, we will print backslash n I will put, so it will start from the new line. Average marks is equals to. Now, if you know, whenever we use %f after decimal, 6 zeros comes. So to that position it gives us data. But I want only 2 decimal. After decimal, only 2 unit I want. So for that I have to use %.2f. So what this %.2f will do, this will give me only 2 values after decimal, right? And here I'm putting backslash n. So all the marks will come after one new line. Now from where this %2f will get the value? I need average. How to calculate average? Sum divided by, so here I'm writing sum divided by n. So sum divided by n, if I will do, it will give me the final average value here. Fine. So here next what I should do, I have to free the space. After once everything is done, you have to free the memory. So deallocation we are doing, and which pointer is doing everything, which pointer is pointing to the memory location? PTR. So free PTR I will write, and that's it, will work for me, right? So let's close this, save. I will compile this GCC sample.c. If any error it will show, otherwise it will come to the next line. As you can see, it's coming to the next line, and here we will run e.exe. So enter number of students. Let us suppose there are 5 students. Enter marks for first student. Let us suppose first student's marks is 20, 14.2, 10.5, 3, and fifth student's marks is 4 point, let us suppose 7. So as you can see, directly it's giving the average marks for the student, and the average marks is how much? 10.48. Now this program, right now we have done this program using Malloc. If I want to convert this program using Calloc, what to do? Calloc, we know Calloc takes 2 arguments. So what will be the change here? I will write Calloc, and here what will happen? Here I will use comma. That's it. That's the only difference, and this program will start working from Calloc. So let's run this, compile this again and run this. So this time let us suppose 3 students. So 4.5, 2.7 and 8. So as you can see, average marks are 5.07. And because of that last percentage %2f after decimal, we are getting only 2 values. Fine. So this is the example of dynamic memory allocation. I hope everything is clear. Thank you so much.